Hello everyone. In this video, we are to see about the working of air conditioners. We know that the air conditioning methods can be broadly classified based on the construction as unitary, central. When we look at the principle and working of these two are the same. They differ slightly based on the requirements and construction. The working of these two are mostly based on vapor compression refrigeration. Yes, the same principle that we have in refrigeration process. Hence, the components and their functions are the same. We have the same components: evaporator, compressor, condenser and expansion valve. In addition to this, we have some minor components like filter and fan. But the major components are the same. The functions are also the same. Even in this one, we use refrigerant. In refrigeration, we mostly use R134A. Here we use R410A. The function is same. The components are same. The refrigerant is slightly modified because the temperature range what we work with is different. In refrigeration, we almost maintain around 0 degrees centigrade. But here, the temperature required is something above. It is something like in the order of around 20 to 25 degrees centigrade. So for that requirement, this refrigerant R410A suits better. That's why it is most widely used. Now, about the unitary air conditioning, we know that the equipment should be placed as a unit in the required place. For example, if this room should get air conditioned, the unit should be placed here, or else a part of the unit should be placed here. That is called unitary air conditioning. Example, something like window air conditioning, split air conditioning. Similarly, there are also other air conditioners which come under this category. Okay, now we look at this window air conditioner. Window air conditioner, as the name suggests, it is a window air conditioner. It is held in window position. Usually we have window at a height of around 3 to 4 feet from the ground, right? In that position is called sill position, sill level. And that position, the base of the window, this is mounted. Even this can be even mounted at a higher position. But this one is quite convenient even to check for later service or something like that. So here it is mounted on window position at sill level. And here we have the 4 components: evaporator, compressor, condenser, expansion valve. All within a single unit. All within a single unit. It comes like this, a single unit. Mostly, if you consider a 1 ton capacity window air conditioner, it comes with the standard size, almost of this size. In the size like 660 millimeter, 430 millimeter. This is the facing thing that we look at in the room. On the other side, it will be around 755 millimeter. So in buildings, while they construct like this, here we will be having an opening which can mount the window air conditioner. Okay. So here we look at the working of it. So here we have the wall. Here we have the wall. The window air conditioner is mounted here. This is the indoor. This is the room which needs to get air conditioned. The air from the room is drawn in. The air from the room is drawn in. Actually, it will be a warm air at the initial stage. It will be a warm air. It will be taken in, and that will be blown with the help of a fan towards the evaporator. In evaporator, we will be having evaporator tubes which will carry liquid refrigerant. The process is very much similar to refrigeration. Now, here once when we pass the room air over this, the heat in the room air will be taken by the evaporator. The heat in the room air will be taken by the evaporator. In the sense, the refrigerant will take the heat and that will convert into vapor refrigerant. Meanwhile, this fan continues to blow so that the air is drawn in, it is blown inside. It is drawn in and it is forced to pass over the evaporator tubes. So what will happen? The temperature of the air will come down and that is sent back to the room. This air does not go out. This air does not go out. Here we have a screen. This screen prevents the air going out. So it continues to go this way. Now we look at the refrigerant. What happened to the refrigerant? The refrigerant comes in as liquid, and here in this process it takes heat and it comes out as vapor refrigerant. This vapor refrigerant goes to the compressor, which compresses the vapor, and high pressure vapor comes out. High pressure vapor comes out. Then it is taken to a condenser, which is cooled by atmospheric air. Atmospheric air is drawn in, and it is forced to pass through the condenser with the help of a fan. So this atmospheric air is drawn and it is forced to pass through the condensing coil. As the refrigerant is at high pressure, that can get condensed in this temperature because it is cooled by the atmospheric air. It gets condensed to liquid refrigerant. What is the next process? It gets compressed, it gets condensed. Now it needs to expand. Using expansion valve, we expand it according to the need. We send the refrigerant back to the evaporator. So the process continues. Until we reach the desired temperature in the room. So we can set a particular temperature. So the room air can be sensed for the temperature, and we can work the system. If we attain the required temperature, the system will go to idle state. And once when the temperature rises, again this process continues to make the required temperature. Again we need to understand another one thing. The summer air conditioning is all about cooling and dehumidification. We need to dehumidify. Here the room air is taken in and it is blown towards the evaporator. In this process, the water vapor present in the room will get condensed to an extent. And that will form dewdrops. And that will go here and get drained on the atmosphere. You can see this. You could have noticed this one, right? And this happens just by gravity. That means that we must have a slight slope. This water droplets will come here and it get drained here. And another one thing, we have a single fan motor. Here this is coupled with two fans. One fan is used to blow the air towards the evaporator, and the other fan is used to condense the refrigerant in the condenser. So this fan motor is coupled to two shafts which gets connected to two fans that does the operation for us. The same thing is explained in another one with the help of a three-dimensional picture. Here we have this room. This room needs to get cooled. Here we take the room air. Here we will be having filters and sensors too. We can set a particular temperature, and based on that the room air is blown towards the evaporating coil and it is sent back to the room. This air is taken and it is blown and it comes out. Here in this process, the evaporating coil will be having the refrigerant, which will get converted to vapor, and it goes to the compressor where it gets compressed, and then it moves to the condenser, which will get cooled by the atmospheric air, and it goes out as hot air because it takes the heat from the refrigerant. It goes out, and here again, here we have an expansion valve which will reduce the pressure of the refrigerant, and we have the entry for the evaporator. Again the same process continues, the same procedure what we have in the refrigeration. So this is about window air conditioning. When we look about the advantage of this one, this comes as a single unit. All the components needed are placed well within this one. So here this can be mounted in the place. The effectiveness is quite good because the refrigerant does not go out. If the refrigerant is taken out to another place, it has to get exposed to the atmosphere. That's why we may have to reduce some power. So here in this case, nothing such is needed because everything is well within this unit. So it can give effective refrigeration, and it is cheaper too because the entire thing is within a single unit. So it is cheaper to an extent. Then when you look at the drawbacks, here we have some drawbacks. because this system should get mounted in a wall which is adjacent to the atmosphere. We cannot mount this on an internal room. If we place it on an internal room, the heat has to get transferred to the neighboring place. It is not possible. So we must have a place like this. On the other side, we must have some space. And if you stand very next to it, we could feel the working because the condenser is there. A slight noise could be there. So this is about the disadvantage. And if another one thing, if we have the provision like this, it's good. If it is not there, if the wall is not having the provision, we need to create a wall with the opening. So we need to have some adjustments or alterations are needed in the room, which is not always accepted. So this is about the working of a window air conditioner. We continue with the split air conditioner. Here we have split air conditioner. In split air conditioner, the unit is split into two. One is indoor unit and another one is outdoor unit. We saw that in window air conditioner, all the four important components were held within. But the prime requirement to make the cooling effect is by the evaporator. Hence, the evaporator is held within the indoor. In the indoor unit, we have evaporator, then air filters, and also fan to blow air. Even we can see this. Here we have the indoor unit. We can open it where we will be able to see the filters, air filters, which can filter the dust particles present in the air. Even that can be removed. We can clean it before and after we can see it. So, in the indoor unit, we have evaporator, the rest three, compressor, condenser, expansion valve. These three are held outdoor. The operation is very much similar to the working of window air conditioner. Again, let us have a quick look. In the indoor, we have the unit. The warm room air is taken with the help of the blower. It is forced to pass through the evaporator tubes. Once when it passes through the evaporator tubes, we will be able to take off the room heat. Heat from the room air is taken off by the refrigerant passing inside the evaporator tubes. So what will happen? These refrigerants will get converted to vapor. That will be taken down to the compressor. That will be taken down to the compressor which is held in the outdoor unit. Here the compressor compresses and it increases the pressure, and again we take the atmospheric air to cool down to condense the refrigerant to liquid form. So we take the atmospheric air and it is given out as hot air because it takes the heat from the refrigerant. Again, the same process is getting repeated. It comes and it expands in the expansion valve. Then it comes back to the evaporator which is held in the indoor. Here we can notice one or two important things. Here it is very easy to mount. We can just have a drill and we can just take the tubes out. Nothing more than that is needed. The tubes are, that is the refrigerant tubes. One is towards the evaporator and another one is towards the compressor. Meanwhile, here as we know that summer air conditioning is all about cooling and dehumidifying. So the water vapor present in the atmosphere, that is inside the room, is condensed and it goes out. So once when we drill the hole, it is held a bit down because by gravity the water droplets should come down through the drain hose. Then once when we take the refrigerant tubes, because in the previous case we didn't have to take this thing like that because everything was held within the unit. Here we have two separate things, so proper insulation should be done in order to reduce the wastage. So proper insulation should be done, and another one important thing to be noted, the separation between this to this should not be greater than 3 meter. If it is below 3 meter, that's good. At certain times we may not be able to hold it within that. In that case, we don't have an option. We may have to extend it, but it is always advisable to have the distance between the indoor to outdoor unit as 3 meter. So this is about the working of split air conditioner. Here it is very much silent because we don't have the compressor within this. If we stand here, we will just have the fan, then about evaporator, nothing more than that. we don't have a compressor which create noise. It is held away. And also we can place this anywhere where we wish. We can mount it on a wall even which is not adjacent to atmosphere. It is not must to mount the system on a wall which is on exterior side. So it's not must. You can even hold it on any place. It's silent. It looks good. So these are some of the advantages of split air conditioner. Meanwhile, we can look at another thing called central air conditioning. In central air conditioning, as we know that the components which do the operation is not held in the place. Especially this is done for huge buildings, say to be an auditorium, say for the entire building. If something to be done like that, we can have it like that. So here we see the top view of a building. Here we have rooms, let it be room 1, 2, 3, 4. Just for a say we have taken 4 rooms and we want to condition the air in the entire building. So what we do is, we want to condition the air. So first of all we take the air out. We take the air from room 1, as it is a huge room, we take it from a couple of places. These things are called ducting. Ducting is done to take air and also to deliver it back. So 2 different lines. One duct takes the air out from this room and also from this room and from this room and from this room. All these air are taken out and it is blown towards an evaporator. The operation is simple and similar to that one. The air is blown to the evaporator where it will be having refrigerant. So of course the heat in the air which is taken from the room gets extracted. Automatically the air will get cooled and that can be blown back to the rooms through ducts. According to the need, we can distribute it. Based on the requirement for particular rooms, we can distribute it. For example, here we have given 1 duct each. For this room here, considering it to be bigger, we have given 2 ducts to distribute the conditioned air evenly. So ducting can be done in the proper manner so that cooling is even. In the previous cases, it's not like that. If we have a unit at this place, cooling effect could be more here but not that much on the other sides. So this is an advantage in central air conditioning. The process is very much similar. Air is taken, here evaporator is there. So what happens? Evaporator, the refrigerant takes the heat and here it goes to the compressor. Here it gets compressed, then here it is condenser. Usually we used to have condenser with the help of atmospheric air which will cool the refrigerant. But as the quantity is more, even we can use cooling towers. With the help of water, we can condense the liquid, condense the refrigerant to form as a liquid. So here it is again liquid. So here we have an expansion valve and it is taken back to the evaporator. Then this process is a cyclic one, it continues. The air from the room comes down and it is cooled and it is taken back to the rooms. This is how central air conditioning works. Here we have to look at one thing. In the previous cases we know that the room air is circulated. We don't give atmospheric air inside. Similar setup is shown here. But in certain places we cannot supply the room air back to the room again. In that cases fresh air is given. For example, in certain critical units in hospitals, we cannot circulate the air which is taken out. In order to have healthy concerns, what we do is the air is taken and it is given out. 100% fresh air is taken and then it is supplied back. But it will affect the efficiency. So a portion of air is removed certain times, portion of air is added. In certain cases, even 100% air is added. This is about central air conditioning. This is done for huge buildings and this is even seen in common in most of the places. And this is about air conditioning and refrigeration. We saw that in advance. So this is about air conditioning and refrigeration. It's good to have some knowledge about these things. Before signing off, I would like to thank each and everyone who are involved with us, especially camera and direction, Mary Shiny, then about the technical support, Geoffrey Jinu, then content verification, it was very well done by Rangaraja sir and Sindhuja ma'am. Not just these people, many well-wishers were there friends and family supported everyone. Thanks to each and everyone. See you again in a new topic. Thank you. Take care.